Right now, there is basically this invisible layer of mathematics making decisions for you.
Yeah, all the time.
Right. It's deciding, how quickly your blood test is processed or when your traffic light turns green or even whether your online order gets rerouted around like a storm system building over the Pacific. And I think we're really used to treating artificial intelligence as a discrete, compartmentalized utility.
Oh, absolutely, like a tool.
Exactly. You make an API call when you need some code written or you open a specific app to generate an image, a tool you pick up, and then you put it down.
And that discrete interaction is entirely how we've been conditioned to view computing for, the last 50 years. You initiate a command, right, and the machine responds.
Yeah.
But the source material we are examining today, which is this really comprehensive AI News Digest from May of 2026, indicates that era is functionally over. What we are seeing across these reports is a major shift. We're moving from isolated computations to continuous ambient adaptation.
Okay, let's unpack this. Because the mission for this deep dive isn't just to read you a list of tech updates, right? We're going to look at these sources and really track how that underlying logic of continuous adaptation is moving out of the laboratory and scaling across our entire world.
Yeah, it's everywhere.
It really is. So we're going to start by looking at how this math predicts biological chaos inside the human body. And then we'll follow that exact same logic as it scales up to our cities, then our global supply chains, and finally, human culture itself.
It's a fascinating progression. And starting at that microscopic level, the biological scale gives us the perfect baseline to understand the rest of it. The digest highlights a major breakthrough in healthcare, specifically a new machine learning algorithm designed for medical imaging.
Right, the scan analysis.
Exactly. The core capability here is identifying minute pre-symptom changes in scans. Changes that serve as early indicators for things like cancer, heart disease, or neurological disorders.
I want to dig into the mechanics of that for a second, because identifying changes sounds like, well, what a human radiologist already does every day. But the digest makes a really clear distinction between human visual processing and this AI's mathematical processing.
Yeah, it's a completely different way of seeing.
Right. Like a human looks for a mass or a shadow, a physical symptom. But the AI is looking at the mathematical relationship between the pixels themselves, right?
Precisely. Human vision evolved to spot macro patterns, like a predator in the brush or a specific shape on a screen. We look for the biological manifestation of the disease.
The actual tumor.
Right. But long before a tumor becomes a visible shape, it alters the tissue density around it. And it does this in ways that subtly shift the contrast of a scan at the pixel level. So the AI has been trained on millions of historical scans. It maps those pixel gradient differentials backwards from patients who, eventually develop the disease.
Wow. So it knows what the scan looks like years before the shadow shows up.
Exactly. It isn't looking at the image the way we do. It is calculating a probabilistic match based on microscopic data structures that our eyes biologically just cannot register.
So it's predicting the unpredictability of biology before the physical problem even exists. And catching a disease early obviously saves lives and lowers treatment costs. But the detail in the source that really reorients this entire conversation, for me anyway, is about the hardware.
Yes, the hardware aspect is huge.
Or rather, the lack of it.
Yeah.
Because this algorithm doesn't require any new specialized diagnostic equipment.
What's fascinating here is how this bypasses the single greatest bottleneck in modern medicine, which is hardware inequity. Historically, when a massive leap in diagnostic capability occurs, it arrives in the form of like a $10 million machine.
Right, which nobody can afford.
Exactly. That restricts top-tier care to elite research hospitals in wealthy urban centers. But this digest explicitly notes that this new AI integrates directly into existing legacy diagnostic systems.
To put that in perspective for you listening, imagine a rural clinic halfway across the world, and they're operating a 10-year-old MRI machine. They don't need to secure massive funding for a new scanner. They just install this software.
Yeah, it's just an update.
It's like installing a software update on an older computer that suddenly gives it a brand new ultra-high-definition monitor. You didn't buy a new screen. The cognitive architecture behind it just learned how to extract entirely new depths of latent data from the exact same sensors.
The raw data being captured by those old machines was always there. We just didn't have the computational filter to make sense of it yet. And by decoupling the diagnostic capability from the physical hardware, this software is effectively democratizing top-tier healthcare globally.
That is just incredible.
It really is. The source notes the healthcare industry is currently grappling with rising costs and severe resource shortages. Deploying a purely software-based diagnostic tool across legacy systems instantly elevates the standard of care, completely regardless of a clinic's geographical location or their operating budget.
So the AI is acting as this invisible layer of optimization, finding order in the biological chaos before it surfaces. But human biology is still, a relatively closed system. Let's take that exact same predictive engine and drop it into an open, highly unpredictable environment.
Moving from predicting biological unpredictability inside the human body, we zoom out to see how AI is trying to predict the ultimate external chaos, which is human behavior in our cities.
Yes, the daily commute.
Right. The digest details a major milestone from a leading tech firm regarding a new autonomous vehicle prototype. Now, obviously, self-driving cars aren't a new concept, but the underlying methodology here represents a really significant departure from previous generations.
How so?
Well, those earlier iterations relied heavily on rules-based programming, augmented by localized sensors. It was a vast, but ultimately finite set of if-this-then-that scenarios.
Right, like if the light is red, apply brakes. If the proximity sensor detects an object at 10 feet, stop.
Exactly. But an urban environment doesn't strictly adhere to those rules. It's fluid and, frankly, deeply irrational. The new prototype highlighted in the text uses deep learning to adapt continuously to new traffic patterns, shifting road conditions, and specifically erratic behavior from human drivers.
It's dealing with us.
Yeah. It isn't just reacting to objects anymore. It is predicting human irrationality in real time.
Okay, here's where it gets really interesting, because I have to challenge this premise slightly. If this car's deep learning system is continuously absorbing data from its surroundings, right? And those surroundings are filled with stressed, unpredictable human drivers cutting each other off, running yellow lights.
Which is pretty much every city.
Exactly. How do the engineers prevent the AI from adopting those exact same bad habits? Like, if it learns from human drivers, doesn't it run the risk of becoming an aggressive, dangerous driver itself?
That is a great question, and it touches on one of the central paradoxes of machine learning in open environments. But the distinction lies in understanding what the system's objective function actually is. It isn't observing a human swerving through traffic and trying to mimic that trajectory.
Okay.
It is learning to identify the latent variables that precede the erratic behavior. It's building a predictive model of the chaos so it can insulate itself from it.
Oh, I see. So it's looking for the tells.
Yes, exactly. Think of a grandmaster in chess playing a novice. The grandmaster studies the novice's erratic, suboptimal moves, not to copy them, but to calculate the probability of their next mistake.
Wow.
The autonomous system does the exact same thing. It notices a human driver drifting, say, 2 inches toward the lane divider while slightly decelerating. It doesn't just see a car. It calculates an 80% probability that the driver is distracted by their phone and is about to swerve.
That is wild.
And then it preemptively adjusts its own braking distance and lane positioning before the human ever crosses the line.
So it's analyzing the micro behaviors of the traffic around it to maintain this sort of defensive buffer. It's reading the pixels of the street the exact same way the medical AI was reading the pixels of the MRI.
That's a perfect way to put it. And the macro effect of that predictive accuracy is profound. The source points out that this continuous adaptation is essential for tackling mounting urban congestion and pollution.
Oh, because of the traffic flow.
Right. When an autonomous system can anticipate slowdowns and avoid harsh braking, it creates a smoothing effect on all the traffic behind it. Less idling and smoother traffic flow lead directly to fewer localized emissions, which pushes us much closer to sustainable urban mobility.
Which brings us to a really fascinating threshold, because we have a predictive engine optimizing a single intersection right now. But what happens when you scale that exact same logic to millions of moving parts across the entire planet? We're moving from a single city to the global arteries of trade.
You get a fundamental rewiring of global logistics. The digest highlights a major shipping company that has integrated this massive AI-based system for its supply chain management.
And supply chains are notoriously complex.
Incredibly complex. This new architecture is analyzing staggering amounts of multimodal data. We're talking satellite weather feeds, port API traffic, global fuel prices, macroeconomic signals. And it uses all of that to predict delays, rewrite shipments dynamically, and manage global inventory levels with insane precision.
I think visualizing the shift here is crucial for you listening, because the old model of a supply chain was essentially a static printed map, A logistics manager draws a line from a factory in Shenzhen to a port in Los Angeles, and the ship just follows the line.
That's the whole plan.
Right. But if a storm hits the Pacific or, a labor strike shuts down the port, that ship just sits there in the water, burning heavy fuel, waiting. It's completely reactive.
Yeah.
But what this AI does is transform that static map into a living, breathing nervous system. And just like a biological nervous system, it instinctively pulls its hand away from a hot stove.
Yes. And in this context, the hot stove is a sudden weather event or a massive port backlog or just a wildly inefficient route that wastes fuel.
So instead of waiting for a human dispatcher in some office to notice a storm warning on a monitor, the system is essentially feeling the atmospheric pressure drop itself. It feels the heat of that delay forming and instantaneously reroutes the ship to a secondary port.
All automatically.
Yeah, while simultaneously pinging the receiving warehouses to adjust their inventory expectations. It reacts to the pain before the pain is actually felt.
If we connect this to the bigger picture, the most profound impact mentioned in the text isn't actually operational speed, it's environmental.
Really?
Yeah. For decades, corporate efficiency and environmentalism were largely viewed as a zero-sum game. The underlying assumption was that optimizing for speed and profit inevitably meant sacrificing sustainability. But this AI proves that efficiency and sustainability are actually perfectly aligned when they are governed by algorithmic optimization.
Well, yeah, because wasted time is literally wasted carbon.
Exactly. A ship not idling outside a congested port is a ship not burning tons of fossil fuels into the atmosphere. A perfectly managed inventory system means fewer perishable goods spoiling in transit and ending up in landfills.
That makes total sense.
By minimizing waste and optimizing these routes dynamically, AI is actively driving greener logistics. It's allowing these massive multinational companies to drastically reduce their carbon footprints, and they do it without sacrificing their bottom lines.
It's just an incredible progression. I mean, we started with an invisible layer of math, removing physical friction inside our bodies by catching disease early. Then we watched it remove the physical friction in our cities by smoothing out traffic. And we just saw it remove the physical friction of the globe by optimizing supply chains.
It's connecting everything.
But the final report in this digest tackles a completely different kind of barrier. We solved for moving physical things, right? Now we're looking at the friction of moving ideas. The ultimate bottleneck isn't physical distance anymore. It's the cognitive distance created by language barriers.
Yes.
The source text details the deployment of a new language processing tool that offers near-human-level translation. And the specific mechanism it highlights is a neural network architecture that actually mimics the human brain's own language processing abilities.
Which is a massive leap.
It is, and we need to clarify what that really means because we've all had translation apps on our phones for over a decade. But those older apps often resulted in these rigid, literal translations that just completely miss the entire point of what you were trying to say.
Because literal translation is often a terrible form of communication. When you translate word for word, you strip the sentence of all its surrounding context.
Right. It sounds robotic.
Exactly. What this source emphasizes is that this new neural network provides translations that are culturally nuanced. And the way it achieves this is through something called vector embeddings.
Okay, let's break that down. How does an algorithm understand culture?
By mapping the relationships between concepts rather than just referencing a dictionary. Older systems saw a word like, say, dog, and just looked for the equivalent string of letters in Spanish or Mandarin.
Just a direct swap.
Right. But this neural network places the concept of a dog into a massive, multidimensional mathematical space. It understands the coordinates of that concept relative to other concepts, like pet, or loyalty, or an idiom like, let sleeping dogs lie. It maps the contextual web of how language is actually utilized by human beings in the real world.
So what does this all mean for a normal conversation? Like if I'm speaking to someone halfway across the world and I crack a joke or I use a highly specific cultural idiom like it's raining cats and dogs.
Yeah.
The AI isn't just translating the weather and the animals, right?
No, it translates the meaning. It identifies the coordinates of that idiom's intent in the vector space, which in this case is heavy, sudden rain. And then it scans the listener's native language to find the specific cultural idiom that shares those exact same coordinates.
Oh, wow.
Yeah. It preserves your tone, your formality, and your humor. The digest notes this is incredibly exciting for businesses, international organizations, and educational institutions. It allows participants from 20 different countries to speak freely with all their natural personality while everyone else understands them instantly with basically zero cognitive friction.
It's tearing down the final wall, separating global knowledge. You aren't just communicating data anymore. You're communicating the human nuance behind the data.
This raises an important question, though. When you successfully remove the friction of language, you fundamentally alter global collaboration. You are allowing ideas to cross-pollinate at a speed and with a depth that has never before been possible in human history.
It changes everything.
It forces us to consider the acceleration of innovation when, say, a brilliant researcher in one part of the world can effortlessly debate the subtle nuances of a theory with a researcher on the opposite side of the planet in real time, with all the subtle context perfectly preserved.
It's almost hard to comprehend how fast things will move when that friction is just gone. And I think that really brings us full circle on the journey we've taken today. We started with a software update that extracts invisible data from old hospital machines to catch a disease before it even forms.
Right.
We looked at cars, calculating the probability of human error to keep our streets safe. We watched supply chains act as a global nervous system to protect the environment. And finally, neural networks that translate our culture, not just our words.
It reinforces the central theme of the digest, which is that AI is no longer a brain in a box waiting for a command. It is an ambient, continuous engine of optimization, seamlessly integrating into the background of our lives.
But before we wrap up, our expert has one final thought for you to chew on, something that builds on everything we've just unpacked, but looks a little further down the road.
Yeah. We've spent this entire deep dive examining how AI is systematically removing all the friction from our world. It's erasing disease symptoms before they happen, smoothing out unpredictable traffic, eliminating shipping delays, and dissolving language barriers.
It's a vision of a perfectly optimized, frictionless future.
Exactly. But as you go about your day, I want you to ask yourself, as our world becomes perfectly optimized, what happens to the serendipity? What happens to the happy accidents, the chance encounters, and the unexpected human discoveries that usually occur entirely because of those frictions?
If the invisible math in the walls fixes everything before it breaks, do we lose the beautiful messiness of figuring it out ourselves? That is an incredible question to leave on. Thank you so much for joining us for this deep dive. We hope it gave you a few aha moments and helped you see the invisible architecture being built all around us. Stay curious. Keep exploring the future of technology, and we'll be right here ready to unpack it all with you.